In this last section to the tutorial, we will focus on finding the area under a curve that falls below a particular z-score value. That is, the entire area that is to the left of a given z-score. Up until now, we focused on finding the area between a given z-score and the mean of a standard normal distribution of 0, or finding the area between two z-score values. But there are times that we will want to know how much area under the curve falls below or to the left of a given z-score. That is, the entire area to the left of a z-score. This is useful for when we're computing percentiles. What we see here in the screen before us are 5 different z-scores that we will use as examples to answer the question, how much area of the curve falls to the left below this particular z-score value. For this first example, we will answer the question, what is the total area under the standard normal curve that falls below a z-score of 1.92? We will begin finding this area the same way that we've done before in the previous examples, by asking what is the area that falls between the mean of 0 and the z-score of 1.92. So we will turn then to our standard normal curve, highlight the row 1.9, add 2 100ths to that, so now we also highlight the column of 0.02, and we see those two intersect at the value of 0.4726. So 0.4726 proportion of the entire area under the curve falls between the mean of 0 and a z-score of 1.92. We now turn to the graph of our standard normal distribution and identify along the base of the graph the value of 1.92 for our z-score. And we indicate here then that 0.4726 of the area under the curve falls between that z-score of 1.92 and the mean of the standard normal distribution of 0. But this is only part of the answer. We were asked to find the total area to the left or below a z-score value. And what we found so far is only that part of the curve that falls between the mean of 0 and a z-score of 1.92. We also, though, need to include the area under the curve that falls below the mean of 0. Going back to the assumptions of a standard normal distribution that is symmetrical, we know that 1/2 of the curve falls below the mean of 0 and 1/2 falls above the mean of 0. So to find the entire area below a value of 1.92 for a z-score, we add 0.5000, which is the area that falls below the mean of 0, to 0.4726, which is the area that falls between the mean of the standard normal curve of 0.00 and our z-score of 1.92. So the result is 0.9726 of the area under the standard normal curve falls below a z-score of 1.92. For the second example, we are asked to find the total area under the standard normal curve below a z-score of 0.49. Turning back to the table for the area under the standard normal distribution, we will first of all highlight the row of 0.4 and then add 9 100ths to that, so we'll highlight then the very last column of 0.09. And we see where those two areas intersect at a value of 0.1879. So 0.1879 area under the curve falls between a z-score value of 0.49 and the mean of 0. Placing the z-score value of 0.49 at the base of our graph of the normal curve, we highlight then the area between the mean of 0 and a z-score of 0.49, and we see that 0.1879 area under the curve falls between those two values. But keep in mind we're asked to find the total area under the curve below a z-score of 0.49. So we then add to that area of 0.1879 the total area that falls below the mean of 0, which is 0.5. So we end up with then, by adding those two areas together, 0.6879 area under the curve falls to the left or to below a z-score of 0.49. For the third example, we will find the total area under the standard normal curve below a z-score of 0.000. Now this is pretty easy, and I'm sure most of you have already figured out what the answer is without even having to go to the area under the curve for a standard normal distribution. But let's go through the same process we've done up till now. So we'll highlight 0.0 in the very first row and add 0.01 to that. So we highlight then the first column as well, and we notice there that 0.0000 area under the curve falls between the mean of 0 and a z-score of 0, which of course we would expect, given that 0 is the mean. So all we need to do then is to ask the question, how much area under the curve falls below a z-score of 0, or the mean of 0? And of course, the entire area to the left, or 0.5000, half of the curve, falls below a z-score of 0.00, which is the mean for a distribution. So the total area under the curve below a z-score of 0.00 is 0.5000, half of the curve. For example number 4, we're asked to find the total area under the standard normal curve below a z-score of minus 0.23. So for these last two examples, we'll be working with z-scores that fall to the left or below the mean. Just as we've done before, we'll take the absolute value of minus 0.23 and go back to our area under the curve for the standard normal distribution, our table. Highlight the row of 0.2, add 0.03 to that, so we'll highlight now the column of 0.03, and we see then that those two areas intersect at a value of 0.0910. So 0.0910 area under the curve falls between the mean of 0 and a z-score of minus 0.23. Plotting the value of minus 0.23 at the base of our standard normal distribution for a z-score of minus 0.23, we now have highlighted or indicated that 0.0910 area under the curve falls between that z-score and a mean of 0. But keep in mind, what we're asked to find is not the area between 0 and a z-score of minus 0.23, but instead the area below minus 0.23. Well, our standard normal curve doesn't tell us that, so we have to then use our understanding of the normal curve to find that value from the information we have. We know that the entire area below the mean of 0 is 0.5000, half of the curve. So we'll subtract from that the area that falls above the value of minus 0.23 and 0 for the mean. So we'll take 0.5000 and subtract from that 0.0910, and that results in a value of 0.4090, which indicates the area under the curve below a z-score of minus 0.23. For this last example, we're asked to find the area below a z-score of minus 2.53. Again, we'll take the absolute value of minus 2.53 and use that to find the area between the mean of 0 and a z-score of minus 2.53. So we look up 2.5 and highlight that row of our table for area under the normal curve, and then we add to that 0.03 or 3/100ths and highlight the column that has a heading of 0.03. And we see now those two rectangles intersect at the value of 0.4943. So 0.4943 area under the curve falls between a mean of 0 and a z-score of minus 2.53.